Have you ever looked up at the night sky and witnessed ribbons of green, pink, and purple light swirling overhead? These mesmerizing displays are known as the Northern Lights, or Aurora Borealis. They are not merely a spectacle for the eyes. They are a dance of science, a beautiful interplay of cosmic forces that evoke awe and wonder in all who behold them. Today, we embark on a journey to explore what they are, how they form, and the intricate science behind this breathtaking natural phenomenon. To truly understand the Northern Lights, we must start with the Sun, our nearest star, a colossal ball of electrically charged gases undergoing constant nuclear reactions. These reactions are not just responsible for the light and warmth that sustain life on Earth, they also unleash streams of charged particles known as the solar wind. Imagine this wind as a torrent of electrons and protons escaping the Sun's gravitational grasp, hurtling through the vastness of space at speeds that can reach 1,000,000 miles per hour. This relentless flow of particles is the first chapter in the story of the Northern Lights. But fear not, for Earth is not defenseless against this barrage of solar particles. Our planet is enveloped in a magnetic field, a protective shield generated by the movement of molten iron in the outer core. This magnetic field creates a magnetosphere that deflects most of the solar wind, preventing it from wreaking havoc on our atmosphere and surface. It's a remarkable system, one that has allowed life to thrive while the cosmos unleashes its fury. Yet, as we look closer, we find that this shield is not impenetrable. At the polar regions, the magnetic field lines curve inward and downward, creating openings through which some solar wind particles can enter Earth's upper atmosphere. This is where the magic of the Northern Lights truly begins. As these charged particles collide with the atoms and molecules in our atmosphere, primarily oxygen and nitrogen, they transfer energy in a process known as excitation. It's a bit like a cosmic dance, where the solar wind partners with atmospheric gases, igniting a spectacular light show. When these energized atoms and molecules become unstable, they release their extra energy by emitting photons, the very particles of light that create the auroras we see. The colors of this celestial display are not random. They depend on which gases are involved and at what altitudes the collisions occur. For instance, oxygen atoms at higher altitudes, above 150 miles, can produce a rare, ethereal, all-red aurora. Meanwhile, at lower altitudes, between 60 and 150 miles, oxygen emits the vibrant, familiar bright green light that is the most commonly observed color in the Northern Lights. Nitrogen, too, plays a role, producing blue or purplish-red hues when excited. The shapes and movements of the Northern Lights are equally captivating, influenced by the lines of Earth's magnetic field and the varying intensity of the solar wind. The display can appear as static bands, dancing curtains, spirals, or even explosive coronae that seem to burst across the sky. Each flicker and wave is a visual representation of the complex interactions between solar particles and our planet's magnetosphere, a reminder of the dynamic forces at play above us. While our focus today is on the Northern Lights, it's essential to acknowledge that a similar phenomenon occurs in the Southern Hemisphere, known as the Southern Lights or Aurora Australis. The science behind both is identical. It's merely their geographic locations that differ. This duality highlights the universal nature of these celestial wonders, transcending borders and cultures. The Northern Lights have captivated humanity for millennia, inspiring countless myths and legends. Indigenous peoples and ancient cultures often viewed them as manifestations of gods, spirits, or omens. For example, some Inuit tribes believed the lights were the spirits of animals or ancestors playing in the sky, a beautiful interpretation that reflects the deep connection between nature and spirituality. These stories enrich our understanding of the auroras, reminding us that they are not just natural phenomena, but also cultural symbols that resonate with human experience. In our modern age, scientists study the Northern Lights not only to understand Earth's atmosphere and magnetic field, but also to gain insights into solar activity and space weather. This research is crucial, as intense solar storms can disrupt satellites, communications, and even power grids on Earth. The delicate balance between our planet and the sun is a reminder of our vulnerability in the face of cosmic forces. Occasionally, the sun releases massive bursts of solar wind and magnetic fields known as coronal mass ejections. When these bursts reach Earth, they can amplify the northern lights, making them visible at lower latitudes than usual. However, these solar events also pose risks to our technological infrastructure, underscoring the importance of monitoring solar activity and understanding the interplay between our planet and the sun. So, where and when can you witness this spectacular light show? The northern lights are best observed in high-latitude regions close to the Arctic Circle. Countries like Norway, Sweden, Finland, Iceland, Canada, and Alaska in the USA are prime locations. The optimal time to witness this celestial dance is during the winter months when nights are long and skies are dark and clear, typically from late September to early April. It's a time when the world feels hushed, as if holding its breath in anticipation of the magic that is about to unfold. Advancements in technology have made it easier than ever to predict auroral activity. Websites and mobile apps provide real-time forecasts based on solar wind conditions and geomagnetic activity, allowing enthusiasts to plan their viewing trips with greater accuracy. This intersection of science and technology opens up new avenues for exploration and appreciation of the northern lights, making the experience more accessible to all. The northern lights continue to inspire art, music, and literature, their ethereal beauty serving as a reminder of the wonders of our natural world and the intricate connections between Earth and the cosmos. They invite us to pause, to reflect, and to marvel at the universe's artistry, to recognize our place within it. In summary, the northern lights are a stunning display resulting from the interaction between the sun's charged particles and Earth's magnetic field and atmosphere. They are a natural wonder that combines elements of astronomy, physics, and earth science, captivating everyone who has the opportunity to witness them. The northern lights are not just a phenomenon. They are a testament to the beauty and complexity of our universe, a reminder that we are all part of this grand cosmic tapestry.